Hi, so we're going to be looking at topic 8.5, acid deposition. So normally rainwater has a pH of 5.6, so rainwater is naturally acidic because there's carbon dioxide dissolved in it. Now, carbon dioxide is not considered as a pollutant because it is naturally present in air. So carbon dioxide is going to dissolve in rainwater to form carbonic acid. Now, for this topic, there's lots of equations that you will need to know. So let's see the dissolving of carbon dioxide in rainwater. So it gives you carbonic acid. So carbonic acid is now a weak acid and it is a diprotic acid, which means that it can give up 2H+. Now, because you have a weak acid in rainwater, this is what makes the pH 5.6. So the dissociation of carbonic acid, so diprotic, so you see it gives up 1H+ and the second H+. Now, anything that causes the pH of the rainwater to be less than 5.6 is going to be called acid deposition. So, acid forming pollutants. So, the pollutants that we have are oxides of nitrogen and as well as oxides of sulfur, so sulfur dioxide, sulfur trioxide. So this is what we have learned to be acid rain. So now we're looking at the term more as acid deposition rather than acid rain. Acid rain has a pH of less than 5.6, and the major pollutants that cause acid rain or acid deposition is sulfur dioxide of nitrogen oxides. Now, when you're explaining, giving your answers, try to avoid the use of acid rain and use the term acid deposition instead. Because when you're talking about acid rain, you're just talking about rainwater, but when you're talking about acid deposition, it can also means like snow, fog, so all these form part of acid deposition. So when you're referring to pollution, it's not just acid rain, but it's acid deposition that is happening. So you have natural processes that produce these pollutants, like volcanic eruptions, like decomposition of vegetation, but you also have man-made causes of these pollution, for example, burning of fossil fuels and you have combustion that takes place in engines. Now, let's see pollution that takes place due to oxides of nitrogen. So these are formed in internal combustion engines, and this happens when nitrogen in the air reacts with oxygen at high temperatures because there's a large amount of energy required to break down the triple bond in nitrogen. So you have nitrogen that is going to react with oxygen to give you oxide of nitrogen. Now, the nitrogen oxide which is formed, this is actually a radical, which means that it has unpaired electron. It does not form an octet. So it is a radical, and as you can see, it has an unpaired electron, which means that it's going to react very easily with something else. So because there is presence of oxygen, so it's going to react furthermore with oxygen. So oxide of nitrogen will react with oxygen to form nitrogen 4 oxide. Okay, now this nitrogen 4 oxide forms smog. Smog is also a type of air pollution, and this is going to react with water, whether it's in the form of snow or fog or rain, to form nitric acid and nitrous acid. So this is why we have acid deposition, because we have the formation of nitric acid and nitrous acid. You need to know these equations. Now, nitrous acid can also be oxidized by atmospheric oxygen to form nitric acid. Hence, all oxides of nitrogen eventually form nitric acid. So you can have the oxidation reaction. So as you can see here, the nitrous acid gets converted to nitric acid. Now let's see the pollution caused by sulfur dioxide. Now, sulfur dioxide is produced when there is combustion of sulfur, and sulfur is present in fossil fuels. For example, coal contains sulfur. So sulfur reacting with oxygen is going to give you sulfur dioxide. Now, the sulfur dioxide reacts with atmospheric oxygen to form sulfur trioxide, and this is a reversible reaction. Now, both sulfur dioxide and sulfur trioxide are polluted, so they will dissolve in rainwater to form sulfuric acid and sulfurous acid. So you have the formation of sulfurous acid with sulfur dioxide and sulfuric acid with sulfur trioxide. So you can reduce the effect of acid rain by treating the fuel first before burning it. So you can just take the fuel, crush it. For example, if you're using coal, so you can just crush the coal, then do a flotation, that flotation method that is going to reduce the amount of sulfur and other impurities. So pre-combustion method is actually just taking the fuel and oxidizing it partially to remove any sulfur or impurities that could cause acid precipitation. Now, post-combustion method is after burning, so treatment of the gas when the burning has taken place. So whatever gas is produced after combustion, we're going to remove sulfur dioxide, oxides of nitrogen, heavy metals and dioxins from the gases before they are released to the atmosphere. And for this we can use calcium oxide. Calcium oxide is quicklime. So we get quicklime from limestone. So you heat limestone, it produces calcium oxide, and this is a basic oxide, so it will neutralize acidic oxide. So this is how it's neutralizing the acidic oxide. Now, ways that acid deposition affects the environment is that it can cause a large number of trees in forests to be affected, so it can result in deforestation, leaching of mineral from soils, leading to high levels of these minerals in lakes and rivers. Uptake of toxic materials from the soil by plants, so it's going to affect the plants. Reduction of pH of lake and river systems, so this is going to affect the aquatic organisms. Increased uptake of toxic metal by shellfish and other marine life. So these shellfish, any organism that produces shell, are extremely sensitive to pH changes, so this can affect them, and it can cause corrosion of marble, limestone or metal bridges, buildings and vehicles. So these are the bad effects of acid deposition. So this is an example of an equation that takes place during the corrosion of marble. So marble is calcium carbonate or limestone.